Welcome to lesson 8, example number 4, and it gives us a column load of 200 kips. So we have 200 kips. Let's write that down. This would be supported on 4 drilled piles. So we have 1, 2, 3, and 4. Not a perfect sketch, but it'll do. And they're all 18 inches into my diameter. 4 18-inch diameter piles. Alright, the frictional resistance of each pile is 500 pounds per square foot, and that's PSF. How deep should the piles extend? Alright, so what I'll do is I'll do this, and let's say we have a 200 kip load. That's how I would take a look at it, and I would say I would assume that this load is going to be equally distributed over all 4 of those. I think that's the intent. So I'd first do 200. That's 200 kips is kind of your P load. Divide it by 4 piles. So that's what, 50 kips per pile. Alright, so now we have a pile. I'm just taking one of those piles. And that's not an S pile. Not a pile that looks like an S. It's a straight up and down pile. And has 50 kip load on there. And it says that's frictional resistance, so skin friction. You could draw these little things, but you don't need to. That's just showing, as opposed to in bearing. This is skin friction. And in typical situations, is when you want to use skin friction, is when you have really deep, decent rock, or when you bedrock's deep, or you just don't have any decent firm soil to bear on. So if you can't get the point bearing, which is when the end bearing is when you don't account for any friction, it's simply bearing on some sort of thing, and you some sort of, let's say you can get 600 PSF, or not, that's a little bit different. Let's say what, 3,000 pounds per square foot, or but in this situation you can't get the necessary end bearing without making these piles just huge to have a huge, this, looking at a plan view bearing area, you'd have to have like 6-foot piles, and that's just, it starts to get really large. And as an engineer, you need to take a look at what is your best way to go. If you had a rock right here, then okay, well, you're not going to do skin friction, you're just going to bear on that rock, because that rock will have a higher allowable bearing. Anyways, I hope that slight bit of randomness in the explaining it helped out a little bit. So we are doing skin friction, and saying that skin friction, the allowable skin friction, is 500 pounds per square foot. So I guess the number one thing is I would figure out, well, how much per foot, how deep does this need to be is what we need to figure out. How long do these piles need to be? So what are we getting per foot? Okay, well, let's go over here. We have 18 inches diameter, so here's your 18-inch diameter. We can just do it like this, 18 inches in diameter. And if you think about it, so this is how we want to look at it. And this is definitely not the scale, so don't think it is. This is going to be a 1-foot section. We're going to assume a 1-foot kind of a unit section, and then we're going to say what is that, where are we getting this PSF from? And that's going to be this. So if you cut it right here, if you took a pair of scissors, let's say this is a pipe pile, and you cut the pipe pile right here, and if you spread it all out, you'd actually get just, if you fold up a piece of paper in a cylinder, and then you unfold it, you have a piece of paper. So when you unfold this pipe pile, I'm going to say fold, if you uncylinderize this pipe pile, you can cut it right there, and you can roll it out. And this is, of course, we're saying is 1 right now. And this distance is what? This is still, we're assuming is 1. If this is 1, because we don't know what we need, for every 1 foot of depth, we have how much area? Well, this is the circumference of that circle. And if you go back to your stuff, the circumference of a circle is pi d. Pi times diameter, or 2 pi r, 2 pi the radius. But we know d, so let's go ahead and throw this in there, pi d. Well, you can go ahead and figure that out, which pi d equals pi times d is 18 inches. 56.55, let's say, equals 56.55 inches. And that's pi times d. And that's per foot. So you're going to have, what, a lot more inches. But we want this in foot, don't we? So let's divide that by 12. 4.71. Let's go ahead and use that. Equals 4.71 foot. All right, so let's take this 4.71 foot, and you want to, let's see, what was I thinking? Oh, we have 4.71 foot times 1 foot. So for every 1 foot of depth, you're going to have 4.71 foot times 1 foot equals 4.71 foot squared, and that's per every 1 foot that you have. So how many feet? Now, actually, let's do this. Per square foot, let's multiply it by 500. So let's take this number times, let's start a new line. And change colors. Keep people guessing here. Okay, so we know we have 4.71 square foot, and that's per foot of depth. I hope that makes sense. And then we're going to multiply it. Okay, so we have 4.71 foot, but we get 500 pounds per square foot. Okay, so let's multiply this by 500 pounds. Because for every time, this is pulling up 500 pounds per square foot. I hope that makes sense. It's resisting. I'm trying to show you the resistance. So for every foot of depth, we are going to have 4.71 times 500. We're going to have 2,355 pounds. And that's per foot depth. This is resistance. So we're going to have 2,355 pounds of resistance per foot of depth. And I hope I explained this the way I meant to. So you're looking at the area of this. And you know what? I think that makes sense. So I'm not going to continue trying to explain that. So for this section, we get 2,355 pounds. And that's only a foot. So how many of these foot sections do we need to resist 50 kips? So we need to, once again, this equals 50,000 pounds. And we need to divide 50,000 pounds by 2,355 pounds, and remember that was per foot of depth. And we take that and go 50, 1, 2, 3 zeros divided by 2,355, and we get 21.23 feet. And when let's see what they have. They actually got the exact same number, 21.23, no rounding issues. And it says they round up to 22 foot. And usually on piles, you will always round up to the nearest foot, and always up. You never want to, this is closer to 21, you always round up. Because the soil conditions are very, very sketchy. You never know exactly what the soil conditions are in any site. They can change. For instance, I've had issues where, you can do stuff 10 feet away, and sometimes you'll find really good soil right here, and the next thing you know, it'll be 20 foot down where you find really good soil. So you always
you always will round up, and even sometimes what we'll do is we'll say you round up and then you add a foot. It kind of depends what you're doing, and make sure you take a look at your code and what it calls out for, and follow that first and foremost. And if you'd like to be a little bit more conservative, you round up even more or have a higher factor safety or anything like that. So I would say, and they say in the, that's inches. They say on the study guide that your answer is 22 foot. I agree with them completely. 22 foot 0 inches is your answer. I will see you on the next video.